Okay, so this is a Unit 6 review. We are testing on Thursday. January 26th. So 1 and 2 are almost the same question. You have different functions, but they have the same attributes. There's 180-degree rotational symmetry about the point 0, 0. They both have an inflection point at 0, 0. These functions are always symmetric about the inflection point. So their x-intercept and y-intercept is at 0, 0. And the domain and range, which I messed this up by doing the same color, but whatever. Domain and range, all real numbers. They're the same attribute, or they have the same attributes. So the cube function looks like this, and the cube root function looks like this, where it goes through 0, 0. That is pretty much the only difference between the two. So then 3 asks, how does the function compare to its inverse? So A says it's rotationally symmetric about -4, 3. Right off, if you graph this, that's not its inflection point. So A cannot be right, because it's always symmetric about its inflection point. Its inflection point is at 4, 3. So the inverse is going to have an inflection point at 3, 4. So B possibly, C definitely not, because it has a -4. That's the x and y intercepts. That's giving you the same point as the inflection point and saying it's an x and y intercept. That's not true. So B has to be it. It's rotationally symmetric about 4, 3, its inflection point, and the inverse is rotationally symmetric about 3, 4, which is its inflection point. And then 4 says graph the inverse of this equation. So in order to graph the inverse, I have to know what the inverse is. So I'm adding on the inside, that means I'm going to subtract on the outside. I have a cube root, so here I'm going to have a cubic. I'm subtracting 1 on the outside, so I'm going to add 1 on the inside. I'm multiplying on the outside, so I'm going to divide on the inside. So this one had an inflection point at -3, -1, so my inverse is going to have an inflection point at -1, -3. It's going to look something like that. And yes, I'm being lazy. but I need to make sure that my inflection point is in the right place. So 5 is similar to 3, saying describe the attributes of this function. So this part is correct, this part is not. My x and y values just switch, they don't change sign and all that. So this one, possible. I'm gonna star it. I know A is definitely out. And then C and D, that point is totally flipped around. So it cannot be C, it cannot be D. So 5 has to be B. The inflection point is at -2, -6. And so the inverse would be at -6, -2. And then 6 looks kind of bad, but it's not really. On the outside, I have +6, so I need -6 on the inside. So I know C is out. That one has +6. So I'm dividing by 3 on the inside, so I need to be multiplying by 3 on the outside, so D is out. So it's in between A and B. The thing to look at is 5. 5 is on the outside. So on the inverse, 5 needs to be on the inside. So even if you can't find the inverse by yourself, you're given answer choices, so you should be able to rationalize which one is correct. So it has to be A. Can't be B. 5 needs to be on the inside. It's inverse, everything is opposite. With the inverse. Placement and operation. So then 7 says solve. So I'm going to divide by -3, and I get the cube root of x plus 4 equals -27. So when I cube this, my answer is going to get pretty big. I have x plus 4, and that's some huge number. -19,683. And again, you're not going to see a response like this that big on the test. And then to check, we'll say -3, math 4. I'll put in my answer, -19,683 plus 4. See, does that give me 81? Oh, it's supposed to be 87. Yes, that gives me 81. So 8 asks, how does this function relate to its inverse? Symmetry, domain and range, x and y intercepts, intersection. So the easiest thing it's easiest to find the y-intercept. The y-intercept is the x-intercept of the inverse. So if I put that in the equation, or in the table, I'll go to y equals 3x minus 1 cubed plus 4. So when x is 0, y is 1. So for f, I'll make a little table. F inverse. So for here, my x-intercept, my y-intercept, we know the domain and range is all real numbers, and the inflection point. So for the original, my y-intercept is 0, 1. So over here, it mirrors across, so my x-intercept is going to be 1, 0. So now I need to find the inverse of this. I kind of need more space. I kind of ran out of space. So I'll be dividing by 3 on the inside of the cube root. I'm going to subtract 4. I'm going to add 1 on the outside. So I'm going to put this in the calculator and find its y-intercept. So I can find the x-intercept of my original. So the inflection point of this is 1, 4. So the inflection point of the inverse is 4, 1. So my y-intercept for the inverse is right around negative 0.1. So that means my x-intercept in my original is negative 0.10. So everything is flipped with my inverse and my original function. They're mirror images of each other. So you switch the x and y values. So the number 9, describe the transformations. So the 1/3 is a vertical stretch, vertical compression. On the inside I subtracted, so that went right 2. And then on the outside I added, so it goes up 4. So then on 10, to find the solution, it's the cube root, so I'm going to cube both sides. So I get 4x plus 7 equals 64. Subtract 7, and then divide by 4. Okay, so I get a decimal. Or you could write it as a fraction.